Okay, so this is example 9.9 from textbooks, okay, which is about determine the stresses on arbitrary plane using Mohr circle plane stress technique. Okay, so the question is the state of plane stress at a point is shown in on the element as shown in the figure. Then represent the state of stress on an element which oriented 30-degree counterclockwise from the position. Okay, so you are given with sigma x is equals to -8 megapascal, sigma y is equals to 12 megapascal, and tau xy is equals to -6 megapascal. So first is to construct the circle. Okay, so the same procedure, which is first you have to determine what is the sigma average. Okay, for this question, sigma average is equals to 2 megapascal. And then next you can establish what is the axis for axis, which is representing sigma, and vertical axis representing tau. And you can locate where is the point C, which is the distance from the origin to the point C is represented by the value of sigma average. Okay, so next is to define what is point A. Okay, using the coordinates of sigma x tau xy, which is equals to -8, -6. So you have to move from the origin about -8 in horizontal and -6 in vertical. So now you have point A as like this. Okay, and construct the straight line from point C to point A, and you will have the value for R, which is the radius of the circle. Okay, so once you have the value for the radius of the circle, so you can construct the circle from the center point C, and you can check the value of R using this equation, which is equals to square root of 10 square plus 6 square, and it is equals to 11.66 megapascal. So you know that 10 is coming from here. Okay, the distance from the horizontal distance from point A to the point C, and then 6 is the vertical distance from point A to the C or origin. Okay, so it is equals to 11.66 megapascal. So next is you have to determine the stresses on 30-degree element. Okay, so that means you have to define what is the value of sigma x prime and tau x prime y prime when the element is oriented about 30-degree counterclockwise. Okay, so to do that, we must construct a radial line called line CP, which is at 2 theta, okay, which is equals to 60. So because the theta is about 30 degree, and then 2 times theta is equals to 60 degree counterclockwise. Okay, so now you have to set this one as a reference line, which is theta is equals to 0. Okay, so this is theta, where the theta is equals to 0. So you have to construct the line CP where the angle is about 60 degree counterclockwise. Okay, from here, and then counterclockwise 60 degree, and you can construct the straight line as like this, and this becomes point P, and this is become point Q. Okay, and then next is to determine the coordinate value of point P, because the horizontal distance from point P to the origin is representing the value of sigma x prime, whereby the vertical distance from P to the origin is representing the value of tau x prime y prime. Okay, so you have to determine these coordinates. Okay, how to determine this one? To determine the coordinates of point P, so you have to know what is this angle, okay, from line CA to this line to the horizontal line. Okay, so let's say I denote it as a phi, and this one is psi. Okay, so what is the value of phi, the angle value of phi? So since you know the information of this triangle, okay, you know what is the value of r, which is equals to you know what is the value of r, and also you know what is the vertical distance from point A to point C, and also you know what is the horizontal distance of point A to the point C, which is 10. Okay, so you can calculate phi is equals to tangent inverse of 6 divided by 10, and the angle is 30.96 degree. Okay, so this is phi. Okay, so next is to determine what is the psi value. Okay, so since we know that this one is 60 degree, so you can just subtract it from 60 degree. Okay, 60 degree minus 30.6, which is phi angle. Okay, and it is equals to 29.04 degree. Okay. Okay, so once you have the psi angle, which is 29.04 degree, so you can determine what is the coordinate of point P. Okay, first for horizontal distance, so sigma x is equals to, okay, so this one is the radius, right? The radius is equals to 11.66. okay, so 11.66, so you have to project this value into this axis. Okay, so since we know the angle in between this one, so it is 11.66 cosine 29.04. So you get the distance from here to here. Okay, but we want to know the distance from point P to the origin. Okay, so you have to minus 2 here. Okay, so since it is in at the left side, and the sign convention is negative, and this one also negative. Okay, so minus negative 2, and you will get negative 8.2 megapascal for the sigma x prime. Okay, so next is tau x prime y prime, which is this one. Okay, so how to calculate that one? So it is equals to, so you know this radius, which is 11.66, and you know this angle. Okay, so you can transform it into vertical axis. Okay, so 11.66 sine 29.04, so you will get the distance, the vertical distance of point P to the origin axis. So it is equals to 5.66 megapascal. Okay, so now we can draw the element when it is oriented about about 30 degree counterclockwise. Okay, so this is the original axis, which is x axis, and then it is oriented about 30 degree counterclockwise. So this is the new axis, which is x prime. Okay, and we obtain the the normal stress here is equals to negative 8.2 megapascal. Okay, so the direction of the stress is inwards because it is negative. And here we have tau xy, which is equals to positive value of positive value of 5.66 megapascal. Okay, so positive is in this direction. Okay, and then to determine what is the value of the normal stress on this plane is you just need to use this equation, which is 11.66 cosine 29.04. Now it is positive here and also plus 2, so you will get 12.2 megapascal for this plane. Okay, for this x prime plane, and tau x prime y prime must be the same as in here, which is 5.66 megapascal. So this one is actually positive. Okay, so positive 5.66 megapascal. So this is the final answer.